So if I'm actually asked to do like what we did on the notes yesterday, like actually work it all out, I always use Pascal's triangle. But if they give me something like this is where I use the n choose r, x to the n minus r, y. Yeah. So, do I know n or r by looking at this problem right now? What's n? 9, right? N is always the right here, so at least got that. N is equal to 9. But the fifth term, you got to think about what would the r be on the fifth term. That make sense? So like, I'm going to just write this one out, and then we can maybe figure out a shortcut that do the different. The first term would be like x to the 9, right, with no y. And then it would go x to the 8, y to the first, the x goes down by 1, and the y goes up by 1. And it would be x to 7 squared. Third. Fifth. Y to the 7. So, is the exponent on, how can we get the exponent for y every time? That has to be, like on this one it would work if we just take 9 minus the term, we always get that. Unless to the term. The first term always has a y to the 0, right? The second term has a y to the first. So I just want you to be aware that the fifth term is always going to have like one less than the term 1. If I asked you for the 8th term, that's the 8th term. That's not what I didn't say. It's not one less. The 8th term. This is the 5th term, which means looking at this, I know r is 4. Yes? That's true. Because I actually worked it out. And I would be left with x to the 5th, y to the 4th. Extra part than what we did yesterday is yesterday they just gave you the number. Today they're giving us the whole thing. So just like what we did yesterday, to find the coefficient, you have to plug those numbers in there too. So not only am I going to do this on my calculator, did you do that yet? 9 choose 4. $126. Yes, that's 126. But the answer to this is not 126 because you have to plug in the first term is 2x. So we have to replace that with 2x to the 5th. And then the y is not y, that would be 1. That would be 1 to the 4th. So we're actually working out that whole term there. So that would be 126 times 32, because 2 times 2 to the 5th is 32x to the 5th. I will set out to be 4,032 x to the 5th That would be it, because the y is just 1. Now we got to figure out the goal. How can we do this without having to work it out? So do another one on this one. Yeah. It's exponent minus the term, because the x starts with that term and goes down. Right? So would that work if I wanted to find the 8th term? That would just be y to the first, though. Is that true? That's not true, though, right? You see what I'm saying? That's how I'm thinking about it. That's why I did that as well. If it was the 8th term, think about that. How many terms are in this one? We're doing the 9th power. How many terms are in it? How do you know what row Pascal triangle is? It's always one more term. So if this is a 9th power, I know there's going to be 10 terms altogether. So if I want to find the 8th term, 8 times 10, I know the 10th term is going to be y to the 10. Y to the 9. Which means this would be y to the 8. And this would be y to the 7. You know what I'm saying? So how? Yeah, so I think this is what I said first. I think that's true. Whatever the term is, the y value is 1 less than that. Does that work on both of these? For the 5th term, the y was a 4. For the 8th term, the y was 7. Let's try the 4th term. Does that work? If we use my rule for the 4th term, the y would be 1 less than that. The y would be to the 3rd power. Is that true? 1, 2, 3, 4. Alright, so you have to just kind of think about what the rule is. It's kind of tricky on that first one because the 5 and the 4 kind of seems like you can do it. So I believe to find r every time, r is always going to equal the term minus 1. Okay, so, or you can just work it out, but I knew there was a shortcut there. I decided to look for that pattern. That's kind of what I want to think about. So let's try a different one. I kind of wrote all of this one. Let's try a different one using that same idea of can we find the term without having to work it all out. Just think about on a test. On a test, if I just ask you for the 5th term and you have to work that all the way out, you're going to waste a lot of time on that one problem. Whereas if you know the shortcut is going to be better. Let's find the 3rd term of x minus 10z. So think for a minute, or write it down. Write it out loud if you don't want. But think for a minute about what is in, using the rule we just came up with, what is r, and could you write that formula? Only 7. If we have the 3rd term, what should r be? 2. Which means now we can work that out. That's y squared. And remember that if you have the formula, it's just n minus r. So 7 minus 2 means that the x has to be 5. Because it's always 1 less than the term that we're on. So whatever the term is, if you subtract 1, and that's because the y starts with y to the 0. That's why that works. And 7 choose 2 you can do in your calculator, but again, you have to plug these numbers in. X isn't going to change in this one. That's just going to say x to the 5th. but my y is negative 10b squared. And that was 17. So you work that out, I think you should get 2100 x to the fifth, and then this one changed to b squared. And honestly, if you don't like Pascal's triangle, you can do that for every middle term of those equations. To me, Pascal's triangle is a lot of, but that's the way that it's going to be the lesson. That's the way it's going to be. That's really the only new idea today. The only other thing I want to do is I want to do the binomial expansion with some crazier stuff like I talked about yesterday with the groups and stuff like that. Just to kind of have fun. So what if I said 5 minus the square root of 3 to the 4th power? So side note, as we're writing this, we got our final schedule this morning all worked out. Of 2, 4, and 6 are on that last Friday, which works out great because I have pre-calculus both 2nd and 6th hour. So you guys won't have your final with me until the very last day. Which means we get all week to study. So it makes me much less stressed about our test not being until like the 11th. We're probably not going to have our test until the Friday before. But then that gives us Monday, Tuesday, Wednesday, Thursday that I'll see you every day that we can review. I normally like to have 3 days to review, so that actually gives us an extra day plus a day that I can send an extra correction. So, yeah, so it's kind of different. We normally always have 7th hour on ours. We switched it up. And then still gives you holiday party. Holiday party, we come here at different stuff. You get extra long lunch. You get like an hour and a half lunch. Every year, you have a little holiday party with cornhole. Well, then this year, big bounce is coming. I know yourself. No big deal. You have no mystery. You don't get one in the springtime, though, right? You only get one in the It's really a holiday party because it's a party for the teachers because they have to. Well, this year they're only going to get subway. I just heard going. Very upset. Alright, so I'm going to do my Pascal's triangle like we did yesterday. So 1, 1, 1, then we just have 1s on the outside. I get this 2 by adding those 2 together. And then 1 plus 2 is 3, 2 plus 1 is 3, and then 1 at the end. And remember that you need 1 more than the number that's there. So that's the 4th power. That means 5 numbers. So I need 1, 4, 6, 4, 1. That saves me from having to do the NCR. Only super fun. Instead of having X's and Y's, we can plug these numbers in and take radicals to hours. Right? So, 1, 4, 4, 1. And the pattern is the X starts with whatever n is and goes down. So the last one has no X's. And the Y is the opposite. So the Y starts with no Y and works its way up. Y squared, Y cubed, and Y fourth. And remember, you can check that the degree of those should always add up to n. So each one of those adds up to 4. So that's how you do it. Hopefully you got lots of practice on that with all the possibilities and homework this year. But the new part is now we're not even going to have X's or Y's left with this. Because this is like my X and this is like my Y. And I'm going to plug it in and I'm going to simplify which means if you take a square root to an odd power, I don't want the decimal, I want us to actually simplify it. So I'm going to plug it in and we'll talk about how this all works, right? So I'm going to get 5 to the 4 plus 4 times 5 cubed. That's times negative square root of 3. Plus negative square root of 3 to 4. Remember, negatives to an even power should give 125. 25 is going to give me negative, and that square root of 3 is just going to stay there, right? I can't simplify the square root of 3 down anymore. So when it's just square root of 3 the first power, it's going to stay there. And then I'm just going to multiply 4 times 5 to the third is 4 times 125. Don't do that. Yeah, because it's just like negative 1, right? So you just bring that negative to the front, because otherwise it's going to be. But then the next one should be positive, because negative square root of 3 squared would be a positive number. And what is the negative square root of 3 squared? Well, what's any square root squared? Yeah, the square root and the square cancel out, right? So that's just negative 3. You square root and you square it at the inverse of it. So that's really just negative 3. No, 3 is negative 3. Negative times negative 3. So then what is that? 25 times 6 times 3. Okay. But then, on the next one, if I have the square root of 3 to the third power, unless you have a fancy calculator, not one I just put on the ground, that simplifies square roots for you. If you type the square root of 3 to the third power on my calculators, it's going to give you a decimal, and I don't want a decimal, I want the exact answer, which means I want you to realize that if you have the square root of 3 to the third power, you could break that up as the square root of 3 squared, and then you have an extra square root of 3 left over, which means just like over here, the square root of 3 squared is just 3, but then you're going to have an extra square root of 3. So you shouldn't have anything higher than square root of 3 to the first power in your answer, because if you have it squared or any number bigger than that, you can always take that perfect square out. So this is really like negative to the third power of 3 square root of 3. So 20 times negative 3 would be negative 60 square root of 3. And the last one, you just have negative square root of 3 to the fourth power, which means you just have double perfect squares, which just means you get 3 times 3. And again, I think on that one, anyone can type it on the calculator. You should get 9 if you type negative square root of 3 to the fourth power, because it's just square root of 3 squared, square root of 3 squared. Which means you can actually simplify this down into 2 terms, because you have all nice integer numbers, or you have some radical 3s. You can add those together, just like you can add 500x and 60x. You can add 500 and 3 and 60. That is minus 5. So that simplifies down to 1084 minus 564. A lot smaller answer because we don't have all these extra lines. Okay. Oh, okay. third power. It'd be a lot worse if it was like the 8th power. 1, 3, 3. It's really not that bad. So when you do fractions to a power, what do you do with the power to a power? What do you do with those fractions? What would I do if I had x squared to the 2/3? You just multiply. Multiplying fractions isn't hard. It's not like adding with a common denominator. And then you look super cool that you can do a problem like this. I stopped here because I need 4 terms, right? 1, 3, 3, 1. Do you ever have math board races on the board? I miss those. You should have board races of like who can do x plus y to the 10th power. Used to with spelling words in 6th grade. That was like our, like, I don't even know what the teacher did at that time. That was like our one word. Like someone would be in charge of some words, like a student. And would 2 people would come up and they would like the races on board. But I quite enjoyed them. I enjoyed them very much. And then they would always come in my camera and next to me. So I start with x to the n and x goes down, y goes up, adds up to 3 every time. I use my Pascal triangle to get my numbers. Questions not where that's from. Because it's y to the 0, right? Like you could put y to the 0 here. Just like down here, I could put x to the 0 if I want, but it's just 1. Right? So I always start with the x, and then I just know that it goes the opposite way. So if you want to, if you start with x going this way, then start with y going this way, and you'll have a lot of people. Another way to check is it has to add 3. So if you already have 3 x's, there's no room for it. If you want to put y to the 3, you can't. I just can't do it because then, super exciting, we get to plug these in. So for every x, we're going to replace it with x to the 2/3, and for every y, we're going to replace it with negative y to the 1/4. Remember that power to a power is just multiplying the exponent. And if you get a fraction, that's okay. You can just leave it a fractional exponent. That is square root. Also know that one of them is negative. It should like alternate signs. That's another pattern that maybe you realized as you did these yesterday. So x to the 2/3 to the 3rd. Right? That's pretty simple. This one I have a 3 and a negative, so I'm going to go ahead and make that a negative 3. And then x to the 2/3 times 2, nothing cancels out. And I just multiply. So 2/3 times 2 is just x. 4/3. And then the y is just y. Because of this negative right here. Because I'm multiplying. So you always want to see whether the sign in the front is positive or negative. Whereas on this one, because it's negative y to the 1/3 squared, because that's even, that's going to cancel that negative out, negative positive. That's going to on this 3. And nothing there. X down. And 1/3 times 2 is just y 2/3. And the last one, if it's negative to the 3rd power, that's going to be negative. And then 1/3 times 3 is y. There's nothing else you can do there. They're not like terms, which means that's your answer. obviously with all those fractals, but it might be numbers or letters or fractals. Okay. So I have a couple, like what we started with, where you just have to give me the term, and then I have a couple like this where you have to do stuff with maybe some square root But this is 9-2 day 2. A couple multiple choice on there. One of them, like which one does not appear in this row triangle. Yeah, you shouldn't actually make calculus on that number. Like use what you can see. Also, don't forget that test questions are due by Friday, and Friday class